Tes. Pandi.
Cek.
Pan, laptop lo harus di mute. Terus speaker laptop lo juga matiin aja.
Matiin ya.
Matiin.
Oke, nanti
juga itu, jadi laptop lo cuman buat share screen karena kalau nggak feedback.
udah saya matiin, masih feedback nggak?
Nggak, udah cakep.
Oke.
Coba ini ya status video ya.
Mantap nih suaranya nih.
Mantep lah. Pak Andre nyeting. Gokil.
Kayak Ustadz Firanda.
Saya mau tausiah, Pak.
Hello, afternoon.
Ini kayaknya sih orang Asia juga deh. Iya, gue sering lihat timnya iya.
Hello, a very good afternoon to everyone.
Hello. Okay, we start.
Okay, so very good afternoon. I'm Samuel. I'm the sales manager for Southeast Asia, representing Big Scientific.
Okay. My name is Pandi. I'm the moderator now.
So Fandi, am I supposed to start the webinar, or we are still waiting for some of the more participants?
Okay, we start now. Okay.
Thank you.
Well, hello smart people in the world. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang Bapak Ibu semua. Welcome back to Lab Indonesia 2020. Saya ucapkan selamat datang dan terima kasih kepada Bapak Ibu yang berkenan hadir dalam webinar BERCA NIAGA MEDIKA hari ini. Di hari ini, kami membawakan topik webinar yang sangat menarik, yaitu Ensure Safety in Laboratory with Gas Generator, yang mana berkaitan erat dengan instrumen kromatografi. PT BERCA NIAGA MEDIKA merupakan distributor instrumen analisis berbasis kromatografi, baik itu gas kromatografi maupun liquid kromatografi. Yang tentunya apabila berhubungan dengan kromatografi, pastinya kita butuh carrier sebagai pembawa si sampel. Contohnya gas kromatografi, dia membutuhkan gas seperti nitrogen ataupun hidrogen. Dan tidak hanya untuk kromatografi, gas generator juga bisa untuk support alat seperti spektroskopi, mass spektrometri, kemudian untuk industri-industri lainnya. Untuk lebih detailnya lagi, dan kita bisa lebih tahu apakah gas generator itu apa aja, kita akan simak bersama pemaparan prinsipal kami dari PIK yang telah hadir di antara kita. Dan jika Bapak Ibu mempunyai pertanyaan, Bapak Ibu bisa langsung ketik di feature Q&A. Jadi Bapak Ibu bisa ketik di situ pertanyaan Bapak Ibu. Kalau misalkan nanti ada yang pertanyaan yang tidak bisa kita jawab, nanti kita akan email pribadi ke Bapak Ibu atau chat pribadi ke Bapak Ibu, atau Bapak Ibu bisa melalui WA care kami. Oke, sebelum memulai, kami ingatkan untuk Bapak Ibu untuk fokus selama webinar kami ini, dan kita akan memulainya. Oke, dikarenakan waktunya sangat singkat, tanpa basa-basi lagi, kita langsung saja. Are you ready, Sam?
Yes, I am. Yes. So
Please
thank
welcome Samuel. The time is yours.
Thank you, Pak Ahmad. Thank you for the introductions. Okay, so first, very good welcome to everyone taking the time off, to attend this webinar. So let's take a look, what am I going to present today? So first, we will talk about a brief introduction to Big Scientific. Follow on, I will also introduce what is a gas generator. We will also look into some gas safety in the laboratory, the features of gas generator that I'm going to share, and also some useful links or readings materials that Big Scientific has prepared for you. Big Scientific. So Big Scientific is a Scottish company. Our headquarters is based in Glasgow, Ishnan Business Park. Big Scientific only focus on manufacturing, I would say, design, manufacture gas generators, targeting scientific applications. So currently, we have about 500 staff that we actually place globally. So let's say within the Southeast Asia, we have in Singapore, we have in Vietnam, Thailand, Malaysia. So for your information, I am sitting in the Singapore office supporting the Southeast Asia market. To date, we have about 50,000 of gas generator installed worldwide. So if you are having some curiosity, Big Scientific started producing gas generators back in 1997. So with 22 years, or I would say 23 years of gas generator experience, we are able to deliver, your gas requirements needs. So I have been mentioning about this word, gas generator. What is a gas generator? This is my definition. It's not a definition that I pull off from the Wikipedia or encyclopedia. It is a box, a device that produces nitrogen gas or purified air from none other than environmental air. So what I mean by environmental air here is the air that is what we are currently breathing in. And hydrogen gas from none other than water. And the raw materials is not just any simple waters like mineral waters or tap water. This water has to be deionized water. So on the very lighter note, jokingly, I would say that, all the gas produced from the gas generators are free, or I would say the raw materials, they are free because, environmental air easily available. Deionized water is easily available in the laboratory as well. So we have been talking on gas generator, we have been talking on gas. So to many of us, we might not know that, there is a certain safety precaution that, the facility managers or the safety managers in the laboratories are looking into, and this category is gas. The current on-site gas storage, let's say nitrogen or hydrogen, can possess many risks. So some of the examples are listed in the slides here. First, we talk about handling of this cylinder tank, because they are heavy, they are bulky. Sometimes I would say the cylinder tank might be taller than any of the laboratory users. So definitely it possesses a risk while transporting from, let's say, point A to point B. Next, we all realize that, cylinder, tank, or dewar gas, they are highly pressurized. So if they are highly pressurized, it can compromise laboratory user safety. We will elaborate this in the further slides. Of course, we can argue that nitrogen is an inert gas. So by saying inert, it means that it is not a reactive gas. However, do you know that nitrogen gas can displace oxygen? And last but not least, hydrogen gas has a potential to reach explosion limit, which means that if there is a certain level of hydrogen gas present in your laboratory, it can create explosion. So these are just some of the key points, key summaries, and now we will look into each individual of these safety hazards. Let's start with nitrogen gas. We know that the environmental air or the laboratory environment, mostly they are made up of 78% of nitrogen, 21% of oxygen, and 1% of other gases. Many of the time, it's no surprise to see that laboratories has oxygen detector installed in the laboratory. But do you know why we need an oxygen detector? Because it's simple as this. Nitrogen can displace oxygen. So what we mean by display oxygen is that it can reduce the total amount of oxygen in our laboratory or in our working environment. So for example, if we put in more nitrogen, oxygen will be reduced. So the ideal scenario is that the laboratory have to be at least 21%, or I would say 18 to 21% of oxygen level. But if we continue to put in or add in more nitrogen gas into our environment, and let's say it reduces 7 to 8% or even 10%, this is where, us as a human being will actually have a reduction of physical or intellectual performance. In other words, we might start to feel a bit giddy. And if we continue to add more nitrogen into the environment, it can eventually cause death. Because why? There won't be sufficient oxygen to be supplied to our body and let our organs to function. So, we have been always saying that, nitrogen gas, the characteristic is that it's inert, it's colorless, it's odorless, it's tasteless. But it is never safe. It is dangerous due to the earlier introduction that it could displace oxygen and causes asphyxiation. So let me put an example. All right, let's say I have a laboratory that measures 5 meter by 4 meter by 2.5 meter. Yes, I know that this is a very small laboratory, but we will obtain a total volume of about 50 meter cube or 50,000 liters. Earlier on, we said that we need to safely maintain the oxygen level at 18%. So in other words, if we are displacing 3% of oxygen, or we add in a further 3% of nitrogen, it could lead to asphyxiation and eventually brain damage or death. So how much is this 3%? It is potentially 1,500 liters. I wish that you can actually capture this figure, 1,500 liters, because it will be applied and it will make sense with my following slides. Traditionally, we don't use gas generator for nitrogen supply. So what we use in our labs, first, we have this, right? Liquid nitrogen dewar tank. But do you know that for liquid nitrogen dewar tank, it is highly pressurized up to about 350 psi. And 1 liter of liquid nitrogen will consist of 694 liters of nitrogen gas. So typically, in the lab, maybe we would see 100 liters of a liquid nitrogen dewar tank or 200 liters of a liquid nitrogen dewar tank. But don't assume that it only contains 100 liters or 200 liters of nitrogen gas. So for example, if I am having 100 liters capacity of a dewar tank, it contains a total of 69,400 liters of nitrogen gas. Another typical supply will be what you see in this picture, nitrogen cylinder tank. Similarly, these tanks are highly pressurized. It will be containing about 2,000 to 3,000 psi or 200 bar. So one cylinder tank, maybe when you place your order, it shows that it is a 47 liters or 50 liters cylinder tank. Again, don't assume that it only contains 47 liters or 50 liters of nitrogen gas. The total gas amount that you can find in this cylinder tank will be 9,000 liters. So earlier on, we said 1,500 liters of nitrogen gas can reduce the oxygen levels to 18% and below. So how much or how many percent of a gas is required from this cylinder tank or even dewar tank to contribute to 1,500 liters? So this is where, today I want to share with you that, while you think that yes, nitrogen gas is inert, but it could be hazardous. Because why? In the event, if there is a leak with this traditional supply, because it is tasteless, it is odorless, it is colorless, we as a human being or we as a lab user, we would never be able to detect nitrogen until we feel giddy. And this is where it could be too late. So this is where, I would like to share with you that, to prevent, all these sort of, I would say, negative issues, we always say this word, prevention is better than cure. That's where, I'm here to introduce you gas generator. It is definitely worth considering to actually replace your conventional supplies with a gas generator with the following benefits. First, because a nitrogen gas generators, it actually the nitrogen gas are generated from the environment air or the laboratory air. It does not increase nitrogen percentage in the laboratory, even if there is a leakage. So in layman term or in simple principle, a generator, nitrogen generator, they are temporarily separating the nitrogen and the oxygen that is in the environment. And after that, it would be returned back to the laboratory. Next, we talk about these nitrogen generators. It is supplied by demand. So for example, if today the generators are connected to an equipment, if the equipment does not require nitrogen gas, the generators will not produce any gas until it calls for. Unlike the traditional supplies, generators are typically low pressure and it have a low storage volume, which again highlight the safety benefits. Next, the interesting thing is that you would never run out of nitrogen gas with a nitrogen generator. Unlike your DWA tank or your cylinder tank, I always joke with my customers, before you run your application, the first thing is not checking on your sample, but rather you want to check the supply of your nitrogen supply. Because why? If let's say you know that today you're running an experiment and it requires a certain volume of nitrogen gas, if this nitrogen gas is not sufficient in the traditional supply, you are wasting your sample, you're wasting your time. Nitrogen gas generator, because of the principles that we actually put in place, it is capable of producing consistent gas quality output. Again, unlike the traditional supplies, which most of the time we will see batch variation. So it's like liquid nitrogen or cylinder tank. We always obtain the certificate of analysis because we are very worried. If this batch of gas is similar to the previous batch, which will again affect our experiment results. Gas generators, definitely, it has a built-in safety features. We actually prevent it from failing or becoming a hazardous issue. Unlike, again, your traditional supplies, which doesn't have these features. And last but not least, PEEK branded gas generators, they are approved by chromatography, or most chromatography manufacturers. So this again gives you a peace of mind that if you are considered big gas generator, it will not create a quality issues. If you are porting over from cylinder tank on liquid DWA tank. Next, we talk about hydrogen safety. I hope I have covered sufficient of nitrogen safety. Let's move on to this. Unlike, I would say, again, I would like to use this same, laboratories volumetrics of 50,000 liters, okay? And currently, I'm comparing cylinder and generator. We mentioned earlier on that lower explosion limits. The lower explosion limits, that means the minimum presence of hydrogen gas in order to trigger an explosion. This is 4.1%. So in other words, if the environment is filled with 4.1% of hydrogen gas together along with oxygen and the spark of ignition, explosion can occur. So if again we calculate this 4.1%, it is equivalent to 2,000 liters. Similarly, I would say the common traditions supplies of nitrogen will be from cylinder tank. Similarly, 50 liters of a cylinder tank of hydrogen contain 9,000 liters of hydrogen gas. So earlier on, I talked about 4.1%, 2,000 liters. That means that, approximately 25% of the cylinder tank is sufficient to meet the lower explosion limits and causing an adverse impact. Well, you could argue, then would it be more dangerous if I talk about hydrogen generator? Because that hydrogen generators, it never runs out. It will continue, to produce. So let's typically put this example. If we are putting in a 500 cc per minute, this is the flow rate capacity of hydrogen generators. It would take about 3 days to fulfill these lower explosion limits. And we are assuming that the laboratory have no air condition, there's no air exchange. So what I'm trying to emphasize here is that, in reality, it is very difficult for a hydrogen generators to meet the lower explosion limit, and it is near impossible. Hence, we always quote this, or we always share this quote, that hydrogen generator is a safer option for you, your colleagues, your workplace, and the environment. There could be some questions that, people start to think, okay, I might not be convinced that hydrogen generators are still safer, because at the end of the day, hydrogen gas is something that we should avoid in the laboratory. So this is where, I would try to explain to you what you could find, or I would say these features that you could find within the hydrogen gas generator. First being that every time when you start up the gas generator, it will conduct an internal leak check. So how it actually conducts is that it will pressurize internally, and it needs to maintain the pressure within a speculated time. So in the event, if there is a leak, we know that pressure will not be maintained, and that's where the generators will recognize that there is leak. And if this happens, you would never be able to actually kickstart the hydrogen generator. Next, we say that it has external leak detection as well. Okay, so this will actually further explain, the second point, that because all the hydrogen gas generators are actually designed with a pressure monitoring system. So in the event, if there is external leak, similarly, the pressures would not be able to build up. And this is where, we actually cleverly set up a system that, if the hydrogen gas generators is constantly building, or I would say making hydrogen gas continuously for 20 minutes, it will recognize that there is an external leak detection. And again, it will shut down the entire system. So coming back, we talk about this golden time, 20 minutes. If we are producing 500 cc per minute of a hydrogen gas for 20 minutes continuously, how much of hydrogen gas can be produced? Total is 10 liters. 10 liters is definitely far too low to meet the LEL, lower explosion limit, of 4.1%. Other than shutting down the gas generator system, if there's a leak that is detected, it will also produce audible and visual alarm. So what you see, on the picture at the lower bottom or the lower right, is green in colors, hologram, But if it is coming to a shutdown, all right, these front panels, instead of green, it will change to red color. And also the buzzers will sound. Of course, we always say that hydrogen generator has a very low storage volume. Maximum volume that is stored within the hydrogen gas generator is not more than 350 cc, and that is equivalent to 0.35 liters. And last but not least, we also allowed external leak detector to be connected to the hydrogen gas generator. So in other words, these external leak detectors are like a probe that we can actually put it into a gas chromatography ovens. So in the event, if there is a leak within the ovens, a certain ppm of hydrogens are being detected, it will send a signal to the gas generator and call for the gas generator again to be shut down. So other than hydrogen gas generator, Peak Scientific has came up a range of gas generator, which we name it as precision range, which are designed to deliver gas dedicated for gas chromatography or GCMS application. And this range will include dry air, zero air, which we call hydrocarbon-free air, nitrogen, and hydrogen gas. And all these different modules that we have, it is made up of a similar footprint, which means that it could be stacked up onto each other, depending on the flow rates and the capacity. The total height of all these generators is weighing between 1.2 meters to 1.6 meters. So other than safety features, why should we still consider gas generator? Gas generator can be applied with a wide range of applications that we could find in the laboratories. So some to name here would be like typically your liquid chromatography mass spectroscopy, GC, GCMS, FTIR, ELSD. Before you even run your LCMS or GC, sometimes you need to conduct some sample preparations. Sample preparation, we know that it requires nitrogen gas as well. TOC system, it needs to have a very clean, dry air, glove box, and sometimes for some purge and calibrations of instruments, you need gas as well. So with such a limited time, let me just talk more on GC and GCMS application. When we talk about GC or GCMS, one of the gas that actually pop up will be helium. Because why? Helium is always the preferred choice of a carrier gas for GC or GCMS application. However, this is a key fact that, helium is getting scarce, is getting lesser, all right? So this is just a slide of, sharing with you what is happening with helium. So back in 1996, the US Federal actually announced that the reserve to be closed. Followed by 2012, there's a planned closure that caused a worldwide shortage of helium. And then next year, 2013, Helium Stewardship Act passed to extend the Federal Reserve operation. And then lately, between 2018 and 2021, the stock acquisition and winding down of helium production facilities. So all these factors actually contribute to helium getting lesser and lesser available globally. So what does this mean? That, if the global helium supplies is getting scarce to the laboratories, of course, it will increase the cost of analysis. Other than increasing the cost of analysis, the operation cost will be higher. I'm not sure if you are facing this situation, but many of my customers is facing the difficulty in sourcing helium supplies, which is the helium cylinder tank. All right, and there's even some reports that currently the gas suppliers are limiting the numbers of tanks that each customers can actually purchase. And all these effects, all these impacts will definitely create a disruption to your operation. So what can we actually counter with all these conditions that we are facing day in, day out? We could actually consider converting from helium to alternative carrier gas such as nitrogen or hydrogen. Okay, and as introduced earlier in my slides, hydrogen and nitrogen can be easily produced with a gas generator. In all, I would just want to sum up with these few pictures that you see in the slides. What are the benefits that you can obtain from a gas generator? First being that it is a 24 hours readiness supply. It will never run out of nitrogen, or I would say any gases from nitrogen or hydrogen. There is a consistent output of a quality. Safety, definitely. Gas generators will offer better safety features as compared to the traditional supplies, because you don't need to trigger any transportation, any deliveries. Of course, you are being social responsible, of being green when you consider gas generators for your laboratories. Next, we also touch base on this, that gas generators can also give you an economical of scale. Okay, because why? Even if you are using 24 hours of a supply from a gas generator, you no longer need to order more gas from the traditional supplier. And then last but not least, you are actually breaking away from third-party dependence. You are being independent. You take care of your own gas control. So together with PT BERCA, we actually train up their engineers, okay, PT BERCA's engineers. We certified them such that we can provide local engineers that actually give you a direct support in this, in the field. Next, although the Peak Scientific office headquarters, regional headquarters is in Singapore, we have a big teams, right, that we could actually provide technical and field support if requires. And last but not least, Peak Scientific advocates rapid response. And we also have ISO quality management deck. We honor same-day shipment of spare or replacement parts to ensure maximize the uptime, or in other words, to minimize your downtime. Because why? At the end of the day, a machine is still a machine. I cannot give you assurance and guarantee that it will never break down. Having said so much, about gas generator, the next question you might have in your mind is like, how do we go about choosing gas generator? Peak Scientific has a various range of gas generators for different needs. So the needs would depend on what we have shared earlier on the application, from LCMS all the way to the purge and calibrations. So we have Genus, Infinity, Precision, iFlow that cater for different applications. So I have come up with a checklist to share with you. First, before we even talk about, gas generator, we need to first understand what application that require gas, because different application will require different gases. So for example, LCMS, we say you need nitrogen gas. If you are doing GCFID, maybe it would require zero graded gas and hydrogen gas. Next, we also need to evaluate if the gas required for the application can be generated with a gas generator. So if today you're coming to me and say, Sam, I'm thinking about using a helium gas generator. Can you please provide me? I'm sorry, I'm unable to provide you a helium gas generator. Because why? In order to produce helium, all right, with a gas generator, I think I might need a generator size of a big building. And then next, we also need to look into what sort of purity is required for this application. What is the flow rate of the gas that is required? What is the pressure that is required? And last but not least, do you want to future-proof for your future purchases? So for example, if currently you are having 1 or 2 instruments, in the next 1 to 2 years, would you be intending to expand your laboratory? Would you purchase more of these instruments? If yes, I would suggest you, take into this consideration of the flow rates required, and instead of getting just nice flow rates for this current sort of application, maybe we can take into the future expansion plan. Peak Scientific, if you are unaware, we have a website, and in our website, okay, we will give you more information and useful links where we talk about product support and also some application notes. So I'm pretty much, I would say, coming to the end of my presentation. I'm not sure if there's any questions, from the participants.
Okay, thank you, Sam, for your presentation. It's a good presentation for me. And any question? Ada pertanyaan untuk Bapak Ibu? Bisa langsung ke feature Q&A Bapak Ibu bisa bertanya langsung di situ. Kemudian kalau Bapak Ibu juga ingin bertanya by pribadi ke kami, bisa ke WhatsApp care kami di 0811 1047 038. Oke, di sini sudah ada question. Question from Anonymous. Besides that safety is very important benefit by using gas generator, how about the cost implication when replace cylinder to generator?
Okay, so in terms of the cost, all right, I would say that I will leave this discussion, all right, to BERCA. But what I will only highlight here is that for the gas generator, definitely, all right, it will be higher than compared with one cylinder tank, all right, because again, I'm unable to tell you that one cylinder tank is equivalent to one generator. But if we look on the long-term cost of ownership, all right, I don't think that you will only need one cylinder tank to do all your experiments. You will periodically need to keep on ordering cylinder tank. However, for a generator, once you purchase it, it is there in the lab for the next 5 to 10 years down the road. And of course, a generator, it will require an annual maintenance, and that is the only cost of ownership. Yep. So I hope I have answered your questions in terms of this.
Okay. The question number 2. If I use nitrogen generator as a carrier gas, what is the important requirement in selecting nitrogen gas generator for GC?
Okay, thank you very much. It's a very good and interesting questions. All right. First of all, I would say, the important requirements. Okay. When we are talking about alternative carrier gas, first, we need to understand what sort of methods that you are using with your GCs. And next, if these GCs allowed for nitrogen carrier gas. And if, today we say that, oh, this is all possible, we can proceed to the next stage, all right, where, we will evaluate what is the conversion methods. A lot of the time, I would say we might need to fine tune, all right, with the flow rates and slightly of the pressure. That's about it. But of course, I'm unable to give you a very satisfactory answer here. I would need to further understand your applications methods before we can advise. So I would say this anonymous attendee that posed this question, please reach out to BNM, all right, so that we can work together with you to provide you a solution.
Okay, thanks Sam for your answer. It's very useful for me and for the others. Karena waktu yang sangat mepet, jadi setelah presentasi dari Mas Sam ini, ternyata banyak sekali ya manfaat dari gas generator buat instrumen Bapak Ibu di lab nanti. Oke, jadi Bapak Ibu, kita tutup saja webinar hari ini. Mohon maaf apabila ada kata-kata yang kurang berkenan. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Share you.
So Ahmad, I think we have one more questions, from another attendees. Can we use same hydrogen generator for carrier gas and support gas for FID? The answer is yes, we can. So in Peak Scientific, we have different range of gas generator. We have one range that is dedicated for support gas and another range for carrier gas. Why we actually have these two ranges is because we know that for carrier gas, it requires a higher purity, or I would say, okay, I try not to confuse you. Okay, instead of saying purity, I would say it requires a drier hydrogen gas, a lower moisture and a lower dew point as compared to support gas. So if you are intending, to use a generators for carrier gas and support gas, I suggest you look into our hydrogen trace range of a hydrogen gas generator. Yep, I think I have answered this question.
Okay. Maybe we can close the webinar session.
Sure. So,
Oke.
okay.
Baik Bapak Ibu, apakah ada pertanyaan nanti mungkin bisa by WA Care nanti bisa email ke kami atau WA ke kami di 0811 1047 038. Jadi oke, kita tutup saja webinar hari ini. Mohon maaf kalau ada yang kurang berkenan dan kata-kata salah dari saya. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Selamat sore.
Thank you very much again for your times, and take care, stay safe. If you have any further questions, please reach out to BNM or, your sales rep or the reps in BMM. Thank you.